Okay, we'll start the class. Am I audible?
Yes, sir, you're audible.
Yes, sir.
Okay. In the last class, we had discussed the mesh analysis or nodal analysis. In the last class, we had discussed mesh analysis or loop analysis. Mesh analysis or loop analysis. In mesh analysis, what we had determined? We had determined which currents? Loop currents. In mesh analysis, we have determined the loop currents. That means there is closed path in the mesh. We have determined the currents I1 and I2 in the loops. Okay, loop currents we have determined. In this class, we will discuss nodal analysis. Right on the side heading, nodal analysis. We will discuss the nodal analysis. Is it visible?
Yes, sir, it's visible.
Yes, sir.
Board is visible? Okay. Nodal analysis. So in nodal analysis, what will determine? We will determine in nodal analysis, we will determine node voltage and branch currents. But in mesh analysis, what you have determined?
Loop current.
What you have determined in mesh analysis?
Loop current.
Loop currents. That is closed loop currents we have determined. But in nodal analysis, what you are determining? Branch currents. In a branch, what is the current flowing? And at the node point, what is the voltage? We are determining at the node what is the voltage, and also we are determining branch currents by using nodal analysis. In nodal analysis, we will apply KCL. In nodal analysis, we will apply KCL. But in mesh analysis, what you have applied?
KVL.
KVL. In the previous class, we have done the mesh analysis. of loop
KVL.
analysis. We have applied KVL. And KCL for determining node voltage and branch currents. What do you mean by node voltage and what do you mean by branch current? Now we will see. See, let us take an example. Write on the problem. Determine the node voltage and branch currents. Write on. Determine node voltage and branch currents for the circuit shown in figure. Determine node voltage and branch currents for the circuit shown in figure. See here. So we are applying nodal analysis for determining node voltage and branch currents. Here in nodal analysis, we will apply KCL. See in this circuit, how many nodes are there? How many nodes are there?
3, sir.
2.
How many? 3.
2. 2. Only 2.
2. Okay. See here. What do you mean by node? I have told you. What do you mean by node?
A point where more than
Where
more
different branches.
wire joins.
2 or more branches joining at a common point. Two or more branches joining at a common point. Let us take this is the node point. Here, how many branches are connected?
3 branches.
3.
Three. One,
Three.
two, three branches are connected. Let us take this is node point 1. This is node point 1. Here also one more node is there. But generally we won't call this as node because this is the reference node or ground node. The voltage at the reference node or ground node is 0. Now we can say that only one node is there in this circuit. Another node is also there, but we'll take one as the reference node. In any circuit, we'll take one node as the reference node. Here I am taking this node as the reference node, ground node. Here also three branches are connected. 1, 2, 3. Three branches are connected. Okay, but I am taking it as a reference node or ground node or at 0 volts. Potential is 0 at this node. Now here we are having only one node. Now I had determined node voltage. I am assuming the voltage at this node. I am assuming the voltage at this node as V1. If there is another node, we'll take it as V2. But here we are having only one node. The another node is at 0 volts. Let us assume that voltage at this node point is V1. Now I had to determine this node voltage and also branch currents. How many branches? What do you mean by branch?
3.
What do you mean by branch?
A wire.
What do you mean by branch?
A wire.
The connection between two nodes.
Pathway.
Joining between two node points.
If you are having two nodes, the line in between two nodes is called branch. Line in between two nodes is called branch. Now see here, in between this node and this node, this is one branch. This is one branch. This is one branch. From V1 to 0, another branch. From this side, another branch. Totally three branches are there. Write on the node point 1. Node 1. Assume all the currents are leaving. See here, the arrow is moving away from the node. This arrow is also moving away from the node. This arrow is also moving away from the node. I am assuming all the currents are leaving from the node. Right? Assume all the currents are leaving from the node point. Assume all the currents are leaving from the node point for determining node voltage. Assume all the currents are leaving from the node point for determining node voltage. This is the assumption for determining node voltage. Now I will apply KCL at this node point. What is KCL? See here, if current is leaving from the node point, what I have told? Positive or negative?
Positive.
Positive. Okay. You know current is equal to V by R. Current is equal to V by R. Now if arrow is moving from this, if arrow is moving like this is at higher potential, this node is at lower potential. V1 is at the higher potential and 0 is at the lower potential. Suppose if arrow is moving like this, 0 is at higher potential, V1 is at lower potential. Now arrow I am considering this side. So V1 positive, 0 negative. That is V1 minus 0. V1 plus V1 minus 0. If arrow is moving like this. If arrow is moving like this, 0 minus V1. Because 0 is at higher potential. Now I am considering the arrow in this direction. So V1 minus 0. So current is I is equal to V by R. V we have written voltage in this branch. What is the resistance in this branch? What is the resistance in that branch?
1
1
ohm.
ohm.
1 ohm.
Okay. 1 ohm. What is KCL? Let us take this is I1, this is I2, this is I3. KCL is algebraic sum of the outgoing currents is equal to incoming currents. I1 plus I2 plus I3. Because all are positive, all are leaving from the node. From this node, all are leaving. If leaving plus I1, it is leaving plus I2 plus I3. I1 is equal to V1, sorry, I have written down here. V1 is higher potential. Arrow is moving from plus to minus. Plus to minus means if arrow is moving from positive terminal to negative terminal, what is the sign you will take?
Negative.
Negative, sir.
V1 minus 10 minus 0 divided by 1. This is your I1. That is your I1 plus I2. I2 is also leaving. V1 is at higher potential, G0 is at the lower potential. V1 minus 0 divided by voltage I have written here. In the denominator resistance is there. What is the resistance?
2, sir.
2 ohms. In that branch, in that path I2, only resistance 2 ohms is there. What is I3 now? That is, what is the current I3?
V1 minus 0 by 3.
Sir,
0 by 3.
V1 minus 0 by 3, sir.
V1 minus 0 by 3. Now take V1 common here. That is 1 plus 1 by 2 plus 1 by 3 minus 10 is equal to 0. Now here bring this 10 to that side. That becomes, if you simplify this, now determine V1 here and tell me the value. Simplify V1 and tell me value. V1. Take LCM. Tell me V1 value.
60 by
11.
Yes, sir. 60 by 11.
60 by 11 or 5.4.
60 by 11.
Yes, sir.
Okay.
60 by 11.
Now I have determined node voltage. In this is the procedure for determining node voltage by assuming all the currents are leaving from the node point. Our assumption is any node you take. Suppose if you are having two nodes, at the two node points, let us assume all the currents are leaving from the node point. Okay. We will do one more problem. Before that, now one more is there. We had to determine branch currents also. Just now we had determined only voltage, node voltage. Now I
Sir,
want to
how we are
determine.
considering that the current is leaving or getting in?
Okay, you can consider also inside current also, no problem. All the currents are incoming also, you can consider. We'll get the same answer. Okay. But
Yes.
generally, in all the textbooks, they will follow all the currents are leaving from the node point. If you want to consider inside also, you can consider. You'll get the same answer. Okay. Voltage will be same, node voltage. But as a general convention, follow one thing in the entire subject. Because we are not only dealing with the nodal analysis. When you go for theorems also, if you are taking incoming currents, you will be confused. If you want to take incoming currents throughout the semester, throughout the subject, you have to take outgoing currents. If you want to take incoming currents throughout the semester, you have to follow incoming currents. I am following outgoing currents. Is it okay?
Yes.
Then branch currents, you see. Here, they have not given the any direction for the branch. Suppose, let us assume that in the problem, they have already given the branch current direction. Let us take I1, I2, I3. These are the directions of current given in the problem. Actual directions given just now I have written. But whatever you have taken, these directions, these are assumption. I1, I2, I3. This is assumption. This is not actual direction of current in the problem. Let us assume that they have given actual directions. This one, I1, I2, and I3. Now we have to determine the actual direction, actual currents, I1, I2, I3, not the assumption currents. Our assumption is only for determining node voltage. That is completed now. Once determining node voltage, we will go for the actual currents. See I1, how they have given in the problem. This is I1. They have given like this. Like this means V1 minus this one. Let us take I1 is equal to V1 is a higher potential. V1 minus 10 minus 0 divided by 1. This is our I1. Now come to I2. What is I2? I2 is flowing from 0 to V1. How will you write I2?
Minus of V1 minus 0 by 2.
Okay. 0 is a higher potential. Minus V1 by 2. Okay, see here. Here we have taken this direction, assumption, V1 minus 0. But here, now we are taking I2 is actual direction from 0 to V1. 0 is a higher potential, plus 0, minus V1, divided by 2. I3. I3 is V1 minus 0 by.
Minus 0 by 3.
Now we know V1. We have already calculated V1. If you want to write the in decimal value also, you can write this one. 60 by 11 is
4.
5.5 volts. Okay. Now substitute V1 here. We'll get current I1, I2, I3. So we have determined branch currents also because we know V1. Substitute V1, we'll get I1, I2, I3. That's all about this problem. We have determined node voltage and branch currents.
Sir,
In
I
node
have
analysis. Any doubt?
Sir, we are getting negative current. It seems that our assumption was in the opposite direction of the actual current.
No. Sometimes it will get negative current also. Okay. It is
So
not our assumption current. They have given in the problem. I1, I2, I3 directions, if they give in the problem, even though we get negative also, no problem. It is not our assumption. They have, let us assume, let us think that it is given in the problem, already given in the problem. I1 direction, I2 direction, and I3. You will get negative values also.
yes, a negative implies that the direction of the current is opposite to that.
Not opposite, it is flowing from ground to node. Okay.
Sir, here
Negative direction.
I2 is V1 minus 0, no, sir. I2 equal to V1 minus 0 by 2.
0 by 2. No.
Here, if we are considering the assumption V1 minus 0 by 2, but actual direction of what they are giving, this is opposite to this direction.
Okay.
Now, if IT is moving like this, 0 is at higher potential, V1 is at lower potential. Now, 0 plus V1 is minus, 0 minus V1 divided. If the arrow is like this, V1 minus 0 by 2. But what is the direction? From 0 to V1. 0 to V1 means 0 minus V1 by. Is it okay?
Yes, sir. Means it's an actual direction, no, sir.
Actual direction. While calculating the branch currents, we have to go for the actual direction of currents. Don't go for the assumption directions. Assumption direction is only for determining node voltage. See the note point what I had told? I had told one note here. Assume all the currents are leaving from the node point for determining node voltage, not the branch currents. Okay. Branch currents, you have to take the actual direction of current, branch current given in the problem.
Okay.
Sir, how do we get that actual direction of the current?
They are given in, they have already given in the problem. Initially I have not mentioned there. Afterwards I have kept I1, I2, I3. See them. They will give
Okay,
in
it
the
will be
problem.
mentioned in the problem only.
What?
It will be mentioned in your.
Previously I have not mentioned. Now I have mentioned the directions I1, I2, I3. Initially I have not given. Actually I have to give, but I have not given. See the actual direction I have given. These are the actual direction I1, I2, I3. This assumption is for determining this node voltage. Only for determining the node voltage will I show. Okay, we'll do one more problem so that we will get clarity. Have you written this?
Yes, sir.
Okay, we'll go for next problem. Determine node voltage and branch currents. Determine node voltage and branch currents for the circuit shown in figure. Determine node voltage and branch currents for the circuit shown in figure. How many nodes are there?
One, sir.
One. Okay. Assume for determining this node voltage V1, I am assuming all the currents are leaving from the node point. This is the assumption. Now I'll write the nodal equation V1 minus 5. Why minus 5 means arrow is moving from plus to minus. This arrow is moving from plus to minus. Minus 0. What is the resistance? Voltage you have
1 ohm.
in numerator. Denominator you have to write all the resistances. Now, what is this value? See the arrow. You have to see the assumption the arrows. This one, and this one. While writing node voltage.
V1 minus
6
6
minus
by 2
V1 minus 6 minus 0 by 2
1 minus 6.
minus 0 by 2.
minus
Why I am taking plus here? All arrows are plus. Leading to the numerator.
Sir, here.
Not visible.
Sir, your camera is off.
1 minute, I am opening.
Okay, sir.
Is it visible?
Yes,
sir.
sir.
Sir, I have a doubt, sir.
Tell me.
Sir, I explained the last sum. It was like 6. Wait a minute, sir. It was 0 minus V1 by 2. Means here also
That
0
is
minus
the
6 minus
actual
V1 by
direction
2.
of I2. But see the first equation when we are writing the nodal equation. When you are writing
You are
nodal
writing nodal or
equation,
actual, sir?
assumed directions.
Okay.
Is it okay?
We are writing nodal, sir. Nodal equation.
Nodal equation now, not the current equations.
Okay, sir.
Because first you have to determine node voltage. Once you know
Yes.
node voltage, then you will go for the branch currents.
Okay, sir.
See, this direction is plus. This direction is also leaving from this node, plus. This direction also leaving from the node, plus. Algebraic sum of all these currents at a node point is equal to 0. That is KCL.
0.
That is V1 minus 7 minus 0 by, what do you get?
7 by 7. 3 plus 4.
3 plus 4. Sum of all resistances in this branch. In this branch, 2 resistances are there. In series, we will add the resistances. In series, resistances will be added. Now determine V1 here. 1 plus 1 by 2 plus 1 by 7. This is minus 5. That is minus 7 by 4 is equal to 0. That is V1 into 14. 14 plus 7 plus 2 minus 5. What is 7 by 4 value? 7 by 4 means how much?
Sir, minus 5, minus 6, minus 7 by 4, no, sir.
Okay, sorry. Minus 3 is
Minus 6
also
also.
there. 6 by 2 is 3. 6 by 2 is 3. Minus 7 by 4.
Okay, sir.
That is minus 5 minus 3 minus 8. Minus 7 by 4. What is the value?
1.7.
1.7. Okay.
7.
7 by 7 also.
How much?
7 by 7.
7 by 7, sorry.
Yes.
7 by 7, that is 1.
Yes, sir.
That means minus 8 minus 1
Minus
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 9.
9.
If minus 9 comes to that side, it becomes right hand side. Okay. Now simplify and tell me V1.
5.4, sir.
5.4. This is your node voltage. We have determined the node voltage by assuming all the currents are leaving from the node point. Now forget about the assumption for determining branch currents. Now we won't consider the assumed currents. We'll consider the actual direction of currents now.
Sir, I have doubt.
Tell me.
In the first equation, in the last term, it should be V1 plus 7 plus 0, no, sir?
V1 not plus, because your arrow is moving from, this is positive terminal, this will be negative terminal. If current flows from positive to negative, we will take minus. In the last class, I also have told you, if current flows from plus to minus, take minus sign, minus 7. If it is interchange, these terminals, if this is negative terminal, if this is positive terminal, means V1 plus 7. Is it okay? If current flows from plus to minus, take negative sign. minus to plus, take positive sign. See, in the previous class, I had told this one. In node point, second node point, in mesh analysis. If current flows from plus to minus, take negative. If current flows from minus to plus, take positive. Is it okay?
Sir,
Yes, sir.
then but V1
Tell
plus
me.
6 minus 0 no sir there.
V1,
V1 plus 6 minus 0.
why? See here, this arrow is moving from plus to minus. This is positive, this is negative. We are not
Okay.
considering these directions. We are considering
Yes.
our assumed directions, these directions, for determining node voltage.
Okay.
Still any doubts? Now we'll go for the actual direction of currents, I1, I2, I3. See I1, what is the direction of I1? Like this. From this node to this node. 0 is at higher potential, V1 is at lower potential now. Now if it is moving like this, 0, what you will get here? 0, what you will get?
Plus 5.
Plus
Minus 5.
5.
So plus 5.
Plus 5.
Plus
Plus
5.
5.
5.
Plus 5.
5 1.
If current is flowing from minus to plus, you will get plus. Minus V1
Minus
divided by
V1.
5. Okay. Next I2. The actual direction of current I2, it is moving like this. In the upward. 0 is positive, V1 is negative now.
0 plus 6 minus
0
V1
plus 6
by
minus
2.
V1 by 2.
Okay.
Hmm.
Next I3. What is the I3 direction? In this direction. That is
Minus
V1
7. Minus 7 minus
Minus
0 by
by
7. V
by
plus
7.
7.
4 plus 3. 4 plus 3 is 7. Okay. Now we know V1. We can determine branch currents I1, I2, and I3. Okay. Write down this. Unit is ampere. Current unit is ampere. That's all about this problem. We have determined node voltage. While determining node voltage, don't see the actual direction of current. We have to assume all the currents are leaving from the node point. We have to consider only assumed directions. But when you are determining the actual current, forget about the assumed currents. Go for the actual direction of the current. These 2 points you remember. While determining node voltage, consider only assumed directions. If you remember this point, it will be very simple. Otherwise, it will be confusing. Okay, we'll go to the next problem. Draw the diagram. Determine node voltage and branch currents. Okay. How many nodes are there?
2 nodes.
2, sir.
2 nodes. Okay. See here. This is node 1, V1. This is node 2,
Sir,
V2.
sir,
Why is it ground?
if we consider the ground side as node points,
Ground node is that one.
no,
I will
the
explain.
downside, if we take nodes on this down below side,
Because ground node is always taken as the common node for all the branches. See here, why I have taken this one means if you take this one as the node, this can be connected here, this can be connected here, this can be connected here. All the branches can be connected at one common point. There is no intersection of the branches there. That's why I had taken that one as the reference node, common node. All the branches are connected to one common point. Most of the branches should be connected. That can be taken as the ground node. Is
no,
it
sir,
okay?
I'm telling that you have taken the node point on the top side, no? So what if we take that on the bottom side? Means, is there any change in the direction?
No. If you take this one as V1, if you take this one as 0,
Yes.
see here, this is the not the common node. Because this node can be connected here, this node and this node. But if you are taking this as a 0 volts, the problem here is all the sum 1, 2, 3, 4. 4 branches are connected to this point. But here, how many branches are connected? 1, 2, 3. So the maximum branches where it is connected, we have to take that one as the ground node. If you take this node, how many branches? 1, 2, 3. Only 3 branches are connected. But if you take this one, 1, 2, 3, 4. 4 branches are connected. So the point where maximum branches are connected, that node is taken as the ground node. Is it okay?
Yes.
Now see here, we have 2 nodes, V1 and V2. Now I have to determine node voltage first of all. If you want to determine the branch currents I1, I2, I3, I4, I5, we should know the node voltage. So for that, what I am doing is, I am assuming all the currents are leaving from the node. Here, for this node, 3 branches are connected. One, this is one branch, this is another branch. So what is this arrow? Where it is connected? This node. Which branch? This arrow is clear from V1 to 0. This arrow is also clear from V1 to 0. Now what is this arrow? Where it is connected? What is the definition for branch?
For V2 it is connected, sir. V1 to V2 it is
V2.
connected.
Okay.
Joining
Any
between
branch
two
is
nodes.
connected in between 2 node points. So this is the branch which is connected in between V1 and V2.
V2.
So this arrow we have to take from V1 to V2 only. Now come to V2. Assume here also all the currents are leaving from the node point. Assume all the currents are leaving from the node point. Now here this branch is connected between V2 and this arrow is from V1 to V2. But this arrow is from V2. If you are writing the first node, you have to take V1 minus V2. If you are writing the second node equation, you have to write V2 minus V1. If you are considering this arrow like this, V1 is at higher potential, V2 is at lower potential. If you are considering this node equation, then you have to consider V2 minus V1. This arrow is moving from V2 to V1. So this branch is, now this arrow is clear. In between V2 and 0, this arrow is moving. This arrow is also clear. From V2 to 0 it is moving. Okay. Now I'll write the nodal equation. See. So at this node we are having 3 arrows. First I am writing this arrow. V1 minus 5 minus 0 by, what is the resistance?
1.
1. Okay. Plus, why plus? Arrow is moving away from the node. V1 minus 7 minus 0
Sir,
by 2.
sir,
Next. Any doubt?
sir, in the first one, write V1 plus 6 minus 5.
Yes, sir.
Oh,
You
sorry,
forgot to
sorry.
write 6.
I am not doing that. V1
Plus,
plus 6. V1 is moving from minus to plus 6 minus 5 minus 0 by 1. Next. This arrow is completed. This arrow is completed. Now come to this arrow. If you come to this arrow, your arrow is moving from V1 to V2. V1 is a higher potential, V2 is a lower potential. V1 minus 8. Minus 8 minus V2
V2 by
divided by, what is the value resistance?
3.
3, sir.
3 ohms.
3. Okay. This is your first equation. So totally 3 arrows are there. 1, 2, 3. 1, 2, 3. 3 terms here. If 4 arrows are there, 4 terms here. Okay, that is your first equation. Now let us go for the second equation. Before going to second equation, simplify all V1 terms on one side. That is 1 plus 1 by 2 plus 1 by 3. Next V2 terms. That is minus V2 by 3. That is equal to 6 minus 5, 1. If 1 comes to that side, it is right here. That is 6 minus 5 is plus 1. 7 by 2 minus 3.5. 7 by 2 is 3.5. 8 by 3. How much 8 by 3?
2.6, sir.
2.6.
Is equal to 0. You can simplify this also. V1 into 6. 3 plus 2, 7. 6. 6 plus 3 plus 2 divided by 6 minus 1 by 3 means 0.33. 0.33 V2 minus, what is this value?
Minus 5.1, sir.
How much?
5.1.
5.1. Is equal to 5.1. Even this can be converted into decimal. Let it be equation 1. Now I'll write the second equation. Second equation, I am taking this. First, I am taking this arrow. It is moving from V2 to V1. That is V2.
V2 plus 8 plus 8.
Plus
8
8
minus V1.
Divide by
3, sir.
one array is completed. Now come to second array. V2, what is this? V2
-9
-9
-0 by 4.
divided by 4.
-10.
V2 -10.
Divided by
0.
5 plus 6, sir.
5 plus 6.
11.
11.
6 and 5 are there in this branch. 6 plus 5 is 11. This now separate, like this, separate V1 and V2 terms here. First write V1 terms, next V2 terms. That is equal to constant. If you solve these two equations, we will get V1 and V2. Okay, don't simplify now. Just write down separate the terms. Afterwards, you can solve this. This much complicated problem nobody will give in the exam. There's simple circuits they will give in the exam. But for your understanding, I am telling this. Separate V1 terms, V2 terms, and constant terms. Then you will get second equation. So for solving any two unknown quantities, we need two equations. If you solve these two equations, we will get V1 and V2. Okay. Now we have got V1 and V2. Okay. Now we have calculated V1 and V2. Now we will go for the actual direction of currents, you see. Don't write, afterwards I will give time. Listen here. I1. See I1. What is the value of I1? Tell me. I1 is flowing from values 0 to V1. 0. What will you get?
Plus 5.
-6
-6
-0.
minus V1.
Sorry, okay.
Who is the
V1
higher potential? V1 is the lower. That is minus V1.
by 1.
This is your I1. Let's see I2. Because we know V1, we have calculated V1 and V2. If you know V1, you can calculate it. I2 is
Plus 7. 0 plus 7 plus 7 minus V1 by 2.
This is your I2. Now tell me I3. See the actual direction of current for I3. How it is flowing?
V1 to
I3 is
V2.
V1 to
V1 to V2. We have to consider this direction, I3. V1 is at higher potential. V1 minus 8. V2 is at lower potential. That's why minus 8. Divided by,
by 3.
this is your I3.
Then I4.
Next I4. I4 in the downward direction is C. V2 to 0.
V2
-7.
V2 minus
-7.
minus 9
9.
by
Yeah, 9.
4.
Now come to I5. I5 is in the upward direction. It is moving like this.
Positive.
0.
0 plus 10 by 11. By 11.
Minus
V2 by 11.
by 11.
So if you know V1 and V2, we can determine all the branch currents I1, I2, I3, I4, I5. Write down this, don't do simplifications now. Later we can do. Meanwhile, I will take the attendance. Any doubts you are having?